In part B of example 1.17, we have the equation g of x is equal to the square root of x plus 2. We are going to take the algebraic approach to finding the domain for this function. Now, we only have the equation at this point, and that's the purpose of finding the domain, is so that way we can then make the function definition properly. The approach that we're taking here is a operator approach, understanding what operations are being done by this function. There are two operations here. There's the addition and there is the square root. The addition operator has no restrictions on it. We saw in part A that the subtraction operator has no restrictions on it, but the division operator did. You were not allowed to divide by 0. In this situation, the square root has a problem. It does have some restrictions. So for example, if I take the square root of 4, the answer would be 2. But if I take the square root of negative 4, that answer is non-real. And I know many of you have had exposure to the concept of the imaginary number. We will eventually be working with imaginary numbers. Today is not that day. So anytime you have the square root of a negative value, we are just going to simply say that it is non-real. Now, in between positive 4 and negative 4 would be 0. And the square root of 0 is going to be 0. So what this is telling me is that from a number line perspective, if I start at 0 and take anything that's greater than 0, that is going to be okay. In other words, greater than 0 or equal to 0 is good. But anything that is less than 0 is going to be bad. We're going to take that idea and we're going to apply it to the equation that we have. So in this equation, I have the expression x plus 2 that's inside that square root. So the square root is being applied to the entire x plus 2 statement. So I'm going to take the x plus 2 statement. Again, this is going to be a algebraic technique. I'm going to take that x plus 2 statement and I'm going to make it to be greater than or equal to 0. When I solve that equation, I will get the statement x is greater than or equal to negative 2. So from a number line perspective, this is claiming that I'm going to have a closed boundary at negative 2 and everything to the right is going to be permissible. That's going to be allowed. So according to this, the domain of G will be hard bracket negative 2 to infinity. Now, of course, if that doesn't set well with you, then you can go and check to see if this actually does work. So this is the old guess and check method. I'm just going to say check. We have x, g of x, and the first value that I'm going to check is the boundary value, negative 2. So watch what happens. When I plug in negative 2, I'll have the square root of negative 2 plus 2, which means I end up with the square root of 0, just like I had the square root of 0 over here, and that's going to give me the answer to be 0, which 0 is a real number. So I am expecting negative 2 to work, and this proves that it does work. Now, you can pick any number you want that is greater than negative 2. Let's say that I pick, let's go with 4. So that's going to be the square root of 4 plus 2, which is equal to the square root of 6. and the square root of 6 is a real number. So therefore, the value that we plugged in is an acceptable value, which the algebraic technique said it would be. Now let's pick something that's not supposed to work, such as -3. Any number that's less than -2 should not work. So if I plug in -3, I would have the square root then of -1, which means I'm taking the square root of a negative number, and that is non-real. So therefore it's not supposed to be there, and we weren't including it anyway. So the check here is just a way for us to actually verify with the equation what the algebraic technique is suggesting. So let me box this in because that is the correct domain. And going into the function definition, the name of this function is g. We just said that the domain would be -2 to infinity. And the domain always has to map to a real number. Every element in the domain has to map to a real number. That is part of the definition for a domain. And this is given by g of x is equal to the square root of x plus 2.